Hi everyone, in this video we are going to practice doing some very simple dimensional analysis problems, specifically non-chemistry related. So these are basic math problems. So the goal of this video is to bring our math skills up high enough so that we could then do the next video, also dimensional analysis practice, where we're actually using chemistry terms. So this one's the math one, the next one's the chemistry one. So let's start off very simply here. All right, so we're going to focus on just dimensional analysis. We're just going to do some basic math. This first question, how many miles are in a 10-kilometer race? Now, it's given to us that 0.621 miles, that's mi, is equal to 1 kilometer, km. Go. All right, did you get an answer? Hopefully you did. We're just trying to work through our math skills here and bring everyone up to the same page. But just in case you didn't, this is how I personally would approach it. You only can start with what you know, right? So in this problem, literally the only number they've given us is 10 kilometers. So that's what you have to start with. So for every 10 kilometers, right, 10's on top, that means you have to put kilometers on bottom. We're trying to go to miles, and thank goodness they gave us an easy conversion of kilometers directly to miles. So all we have to do is plug these numbers in. So 1 kilometer is equal to 0.621 miles. Our kilometers cancel out, and now we are left with a unit just in miles. All we have to do is multiply 10 times 0.621, and if you do that properly, you end up with a final value of 6.21 miles. So if your friends are like, ooh, I just ran 10 kilometers, you can be like, psh, that's only 6 miles. Only, right? Next question. All right, so the moon is about 250,000 miles away. How many feet is that? Go. All right, hopefully this is getting just a little bit easier after that last problem, but let's just see if we got the answer right. If you got a giant number, then you're probably on the right track. All right, so first thing you have to do, start with what you know. The only number we were given is 250,000 miles, okay? 250,000 miles. Luckily, again, we were given another equation that takes us directly from the unit we're in to the unit that we want to go. So we have miles on top. If miles is on top, we have to have miles on the bottom. We're trying to go directly from miles to feet, but we have a conversion factor, so we just have to plug this in. For every 1 mile, we have 5,280 feet. So all we have to do is multiply these two numbers together. 250,000 miles times 5,280 feet. Miles cancel out, we're left with feet, and you get this giant number, 1,320,000,000, feet. That's your answer. Now, that's pretty ugly. There's a lot of commas, a lot of zeros. Personally, I would try to report that in scientific notation. So right away, what you do is write 1.32 times 10 to the, and we're trying to figure out what that number is going to be. So let's figure it out here. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Whew, that's a billion. That's huge. 1.32 billion feet away. That's how far the moon is, or 1.32 times 10 to the 9th feet. All right? Now, scientific notation is something that usually gives students trouble for whatever reason. So what we're going to do here is give you one more problem, a simple conversion again, but you have to use your scientific notation and make sure you're using that properly. All right, so try to tell me how many liters are in Lake Michigan if you know that there's actually 1.3 times 10 to the 15 gallons of water. Go. All right, did you get an answer? Hopefully you did. It's pretty much the same thing we've been doing, except for we've added this little bit of a factor of scientific notation. But again, we've only been given one number, so you just have to start with what you know. So we have 1.3 times 10 to the 15 gallons. I'm just going to abbreviate it GAL because that's pretty common. So we have gallons on top, which means we need to put gallons on bottom. We have a conversion factor here again that takes us directly from gallons to our desired unit of liters, so we can just use this. So we have gallons on the bottom, that's going to cancel out. Liters on top, we just need to put our numbers in. 1 gallon is equal to 3.79 liters. Gallons cancel out, left with liters. All you have to do is multiply these together. 1.3 times 10 to the 15 times 3.79. If you do that correctly, you would get something like 4.927 times 10 to the 15 liters. Whew, that's a huge number. Really, really big. Now, if you did not get that number, that probably means you're not using your calculator correctly. So yes, this was a simple problem, but we need to review scientific notation. If you are typing that number in, so the 1.3 times 10 to the 15, if you're writing 1.3 times 10 caret raised to 15, you're doing it incorrectly. You need to be using that little EE button. So you should be typing in 1.3 EE 15, all right? So if you're typing 10, the number 10, you're doing something wrong, and you're very, very likely to get these problems wrong on an exam or when you're in a stressful situation. So please just switch over to the new method right now. 1.3 E15 times 3.79, bada bing, bada boom, you get the right answer. All right, so now I've ramped it up a notch. We're taking it to the hardest problem in this video. I'm not going to give you any extra information. You should be able to do this with what's already in your brain. Please tell me how many seconds are in 1 year. Go. All right, did you get an answer? Hopefully you did. This is a little bit of a longer problem, but in theory, you have all the skills and all the information to be able to do this on your own, but just take your time. Do not rush. So the only information we have here is that we have 1 year. We're starting with 1 year. So we're going to start over here, 1 year. If year is on the top, then we need to have year on the bottom. So for me, when I think about this and I'm trying to break it down into seconds, I think it's easiest to go from years to days. So I know that there are about 365 days in every 1 year, right? So now we're in the unit days. If days is on top, we need to put days on the bottom again. So for every 1 day or days, that's fine, we know that there's approximately 24 hours. So 24 hours in every 1 day. Let's start canceling off these units so it's a little bit more clear. So year cancels out, day cancels out, day cancels out. We're left in hours, so that's good. We're getting closer to seconds. So now we can do for every 1 hour, if hour is on the top, hour has to be on the bottom. For every 1 hour, we know there's 60 minutes in every 1 hour. Our fancy math people probably could have jumped right to seconds here, but that's just if you're super fancy. For the slower ones of us, we can just take it nice and slow here. So we've got 1 hour for 60 minutes. Now our hours have canceled out with that, so that's great. We're left in minutes. We're super, super close. We just need one more conversion to get to seconds. So if minutes are on the top, minutes have to be on the bottom here. Then we can go directly to seconds. We know in every 1 minute, there's 60 seconds. Now, some of you might have gone 1 hour, there's 3,600 seconds. That's totally fine, but you just know that there's multiple different ways to do this. All right, so last thing, minutes cancel out. We're left with seconds. I'm running out of room, so I'm going to come down to the bottom. So what you should have done is 1 times 365 times 24 times 60 times 60. If you did that properly, you ended up with something like 31,536,000 seconds. And again, you can do scientific notation if you want. So 3.1536 times 10 to the 1, 2, 3, 4, 5, 6, 7. So 3.1536 times 10 to the 7th seconds in 1 year. Whew, that's a lot. That's just basic math, okay? This is the skills that I hope you had coming into this class. Now what we have to do is put a little chemistry on that and have fun. We're going to blow some stuff up, do some calculations, figure out how much fuel you need to actually blow something up. But if you can't do this, the basic mathematical conversions, you're really going to struggle once we start speaking in the chemistry language, okay? So make sure you're good with this. If this wasn't easy for you, just go back, Google dimensional analysis problems worksheet, and just drill until this makes sense with you. Or call me. Well, don't call me, but set up an appointment and email me or talk to your teacher, all right? Have a great week. Take care of yourself and drink water.